So in this video, we're going to talk about the Lewis structure of carbon monoxide. So carbon monoxide has the oh, that didn't go well. But carbon monoxide has the molecular formula CO. It's a potent poison, and I've actually made a video about carbon monoxide poisoning and its mechanism, right? So the first thing we need to know is how to get the number of valence electrons for each atom, because remember, the number of valence electrons determine the bonding, right? So the first thing I'm going to do is write my atoms and then say to myself, how many valence electrons do each atom has? So if I look at the periodic table, carbon has 4 valence electrons, while oxygen has 6. If you don't know how to derive these numbers, then I've made several videos in the past that you could go ahead and look at and see how do we come up with the valence electrons, and we simply get those from the periodic table. So after we've not calculated, but after we got our after we get our valence electrons, then let's talk about the total electrons that we have to place. And so 4 plus 6 is simply 10. So in my Lewis structure, I should have 10 electrons total. So I only have 2 atoms, so I could just go ahead and place the atoms apart. I know I at least will have to form a single bond. Now, this single bond, interestingly, consists of 2 valence electrons, right? Because we have one from the carbon in this case and one from the oxygen. So we've only used up 2 out of the 10 that we have to place. So we still have 8 more to place. Now, if you remember, carbon and oxygen are 2 of those atoms that must satisfy the octet rule. So we need to find a way to put this structure together where both oxygen and carbon has 8 valence electrons around them total. So at this point, we only have 2 for carbon and oxygen respectively. So I'm going to go ahead and form a double bond, right? And so if I form a double bond, now I'm looking at 2, 4. So now I'm looking at 2, 4. So that is 4 valence electrons that we've used out of the 10. So we still have 6 more to place. Now, in this case, I'm going to form another bond and see where do we go, right? This is an experiment in most cases. So this becomes 2, 4, 6, right? And so we have 4 more valence electrons to place. Now, oxygen here, what's its octet? We have 2, 4, 6. So oxygen needs 2 more electrons to get its valence filled, right? So now this becomes 2, 4, 6, 8. So oxygen is satisfied. What about carbon? We have 2, 4, 6. So I could put 2 more electrons around carbon, and let's see if that satisfies the octet rule. So now I have 2, 4, 6, 8 around the carbon, and I have 2, 4, 6, 8 around the oxygen. So this would be a plausible structure for the carbon monoxide molecule. Let's count how many electrons we've used total. So this would be 2, 4, 6, 8, 10. So this would be a plausible structure. Now, why couldn't it be, let's say, for example, if I had went this route, right? So this is the correct structure. Now, let's say, for example, I had went this route where I have, right? So let's say, for example, I had a double bond. Why would this be wrong? Right? So now I have 2, 4, 6, 8 around carbon. And in this case, let's fill oxygen's valence, right? This would be 2, 4, 6, 8. So notice that the octets are actually satisfying both of these, but let's count how many electrons we've used. We've used 2, 4, 6, 8, 10, 12, right? We've used 12 electrons here, which is not what we've counted initially. So this could not be a plausible structure for the molecule and anything else that you may derive.